Hello, everyone. Mr. Minnick's my name. Math is my game. This is 7 o'clock, Mr. Minnick. And today, what we're going to look at is called Matrix Basics. I know it kind of rhymes. But anyway, in studying systems of equations, a lot of times um, we study a variety of ways to solve them. If you recall back to Algebra 1, if you had a system of equations, with x plus 3y equals 10, and maybe y equals negative 1 half x plus 6. If you saw something like that, you might learn how to solve that with the substitution method, where you would take this quantity, negative 1 half x plus 6, and because the second equation is solved for y in terms of x, you could go ahead and plug that quantity into y right there, and that would give you one equation with one variable. You could get x and then go back and get y. And also you learned how to solve that with linear combinations, and we're going to revisit those ideas maybe later this week. If not this week, next week. So anyway, what we're going to talk about today are matrices, okay? So the singular form of the word is matrix. Matrix. That's the singular form. Singular form. If you're talking about more than one matrix, the word is matrices, or matrices, as I like to say. So that's plural form. The reason I'm mentioning this is some people want to talk about there being a matrice. Well, there's such a thing as a matrice, but there's no such thing as a matrice. And if you're talking about more than one matrix, they're not to be called matrices, they're matrices. Okay, I know that's a weird thing, but it is a thing. So be aware of that. So you're probably thinking to yourself, well, he didn't say anything at all about what a matrix is. So here we go. Here's the definition. A matrix is a rectangular array. Oh, that's weird. A matrix is a rectangular array. Do you see what I tried to do there? Probably not a good idea, and it's not very rectangular. But a matrix is a rectangular array of elements. I'll call them elements. Of elements, asterisks. What are elements? Well, they could be numbers. They could be variables. They could be words sometimes. So we'll just say a matrix is a rectangular array of elements into horizontal rows and rows and vertical columns. Hopefully you kind of see what I did there. So rows are the series of elements that go across. Rows are a series of elements that go across. One of those is called a row, and columns are the series of elements that go up and down to form a column. If you think back to the ancient Greeks, when they were building buildings and they had columns, in front of the Parthenon, those things. So that's how I kind of remember columns. Okay, and if you think about the horizon with the sun, the horizon, that was supposed to be yellow. That didn't work out so good. Let's try that again. The horizon. Right? It's okay. All right, so a matrix is a rectangular array of elements into horizontal rows and vertical columns. Okay, so that's the definition. Matrices, let's switch back to another color that's going to show up. I haven't used my calligraphy pen all year, so I'll go ahead and use it. Matrices are named using a single one, capital, see what I did here? A capital letter. Now, I need to pause for a minute and say, when I show you on the TI Nspire, the TI Nspire only uses lowercase letters for variables. And that's one thing that kind of bothers me. But when you name a matrix, you use a capital letter, okay? Elements within a matrix, elements within a matrix are identified in a special way, are identified using, this is a lot of writing, I know, a lowercase letter a lowercase letter that corresponds to the name of the matrix. So if you name the matrix capital A, you're going to use lowercase a. Okay, so elements within a matrix are identified using a lowercase letter that corresponds to the name of the matrix, followed by two subscripts, colon. The first subscript indicates the row the element is in. The row the element is in. The first subscript indicates the row the element is in. So you could probably guess what the second subscript indicates. The second subscript indicates the column the element is in. I really don't like ending sentences with prepositions, but there you go. Elements within a matrix are identified using a lowercase letter, which corresponds to the name of the matrix. So if the name of the matrix is capital B, you'll use a little b. Followed by two subscripts. The first subscript indicates the row the element's in. The second subscript indicates the column the element is in. So there's one more thing we need to talk about prior to actually looking at a matrix, and then we'll be able to get right to it. So the last thing we need to talk about are the dimensions of a matrix. The dimensions, we'll say that the dimensions of a matrix are, and I'm going to switch colors and markers here, are by C, where R is the number of rows the matrix has, and you guessed it, C is the number of columns the matrix has. So usually what happens when I try to show this to students is they get it switched around the first time, maybe even the second or third time. But after you see enough of these, you'll get the hang of it. Remember, horizontal rows, vertical columns. So the dimensions of a matrix are said to be R by C. So when we talk about them, it's some number by some number, 2 by 2, 3 by 3, 5 by 7, something like that. So the first number is how many rows the matrix has. The second number is how many columns the matrix has. So at this point, I think it would be a great idea, to actually look at some matrix. Okay. So we use a capital letter, and I've already got 3 matrices on my TI Inspire, so I don't want to use any of those capital letters to be confusing. So here's a matrix. Here is a matrix. I'm going to go ahead and name it capital D. Use a capital D. And I almost forgot, when we close in matrices, we actually use big brackets. You know, we use parentheses for ordered pairs. We use braces for sets. And when we're talking about a matrix, what we use are large brackets. Okay? So matrices are named using a capital letter. Maybe we want to add this. Matrices are enclosed with brackets. Matrices are enclosed with brackets. Okay. So a matrix. Here's matrix D, and I'm going to put it's a rectangular array of elements. So I've used Kool-Aid Man before. I'm going to use Kool-Aid Man again. I love Kool-Aid Man. Oh yeah. So there's Kool-Aid Man. Kool-Aid Man's the first element in this matrix. Maybe I'll put SpongeBob. Oh my gosh, look how big SpongeBob is. Wow. Maybe I'll put SpongeBob as another element in this matrix. Okay, so there's SpongeBob. Yay! All right. So we got Kool-Aid Man, we got SpongeBob, and maybe we want to put some character like an emoji. Is it emoji? Some emoji, like a smiley face. Like a smiley face. Maybe we could put some kind of shape, like what seems to be a square. And now we can clearly see that it is a square. All right. Maybe we'll put something else like the number 9. Maybe we'll put something else like the opposite of pi. Maybe we'll put a Greek letter in there like omega. And finally, maybe we'll put something else in there like a word. Like a word. Red. Red, 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 red. Sorry, that was my Blake Shelton. I was thinking about the boys around here. Okay, so that's a matrix. We can see that this matrix has 1, 2, 3, 4, 5, 6, 7, 8 elements in it. So if you think about the number 8 for a minute, and this is just totally a sidebar, but if you think about the number 8, the number 8 could be factored into 1 and 8 and 2 and 4. And we notice that there is some kind of, there's 2 of these things, right? There's 2 of these things, and then there's, let's try that again. There's 2 of those, and then there's 1, 2, 3, 4 of these things. So when we talk about the dimensions of this matrix, remember, we got to identify what the dimensions are. So let's look at this matrix and let's think about this. The dimensions of matrix, the dimensions of matrix D are as follows. So it'd be nice if I didn't draw that weird L shape. I was trying to use my smartboard, and it gets confused sometimes, as do I. But if we're talking about the dimensions of matrix D, we need to remember what rows are, what columns are. Rectangular array of elements into horizontal rows. So rows go across. So in other words, this is the first row. Maybe you want to make note of that. Maybe you want to make note that that's row 1. Okay, so this is row 1. And then going across here, this is row 2. Going across here, this is row 3. Now, obviously, you're not going to want to do this every single time because it's a waste of time. But for now, to help us figure out the dimensions, this is a good thing. So we have 4 rows. Similarly, going downward, this is column 1. And oh, let's try that one more time. All right, smartboard, you win. And over here, this is column 2. Column 2. So when we talk about the dimensions of this, some people are going to say it's a 2 by 4, and some people are going to say it's a 4 by 2. Well, one of those answers is right, and I hope you know which one's right. How many rows? 4 rows. How many columns? 2. The dimensions of a matrix are R by C. We said the dimensions of a matrix are R by C. How many rows? 4 rows. How many columns? 2. This is a 4 by 2 matrix. Okay, this is a 4 by 2 matrix. Hopefully everybody kind of has that idea on lock. The dimensions of a matrix. Okay, so I'll go ahead and get that stuff kind of out of the way for now. And the next thing we want to think about is how to identify particular elements. Okay, so remember we said elements are identified using a lowercase letter that corresponds to the name of the matrix, followed by two subscripts. The first one indicates the row, second indicates the column. So if we're talking about this smiley face, if we're talking about smiley face is identified as what? How would we identify smiley face? Well, the matrix is capital D, so we're going to use a little d. And remember, we use two subscripts. The first subscript indicates what row. What row smiley face is in? Well, smiley face is in the second row. And the second subscript indicates what column. And smiley face is in the first column. All right? So if we're talking about omega, we would say omega is little d sub 4 sub 1. What about the opposite of pi? The opposite of pi, in this case, is identified as little d subscript 3, third row, 2, second column. Okay? So you're going to have to be able to do that on Friday's test. Hopefully you're all right with that material. So a couple final things that we need to say about matrices, and that'll be it for today. I've gone and taken the liberty of putting in some matrices. We can see matrix A here. Matrix A here is a 2 by 3. Let me just go ahead and recall the variable A. So A is that 2 by 3 matrix. B is a 3 by 4 matrix. So what I'm going to try to do, I've got matrix A, it's a 2 by 3. And I've got matrix B, actually capital A and capital B. Okay, I'm going to try to multiply these matrices using the calculator. We're not going to do these by hand today. So let's see if the product matrix exists. Let's see if we can multiply a 2 by 3 matrix by a 3 by 4 matrix. Okay, so I'm going to try to take A times B. And when I do that, I end up with a 2 by 4 matrix. I end up with a 2 by 4 matrix. Now, if I try to multiply this matrix, these two matrices in the opposite way, 3 by 4, a 3 by 4, which is B, by a 3 by 2, by a 2 by 3, which is B, I want to see what happens here. I want to see what happens with the matrix B times A. Let's see what happens. Maybe we can't even do this. B times A. Dimension error. A list or matrix is not valid. Matrix index is not valid because it only contains 4 elements. Ooh. So what we say in terms of matrix operations is we say that because that happened, this really stinks. We would say, this really stinks. That abbreviation PU stands for the product is undefined. The product is undefined. So the fact that we can multiply A times B and we get AB, but we can't multiply B times A, this leads us to one of the discoveries that's one of the 44 content standards. Matrix multiplication, write those down. Matrix multiplication is not commutative. Matrix multiplication is not commutative. That's something you're responsible to know. It's one of the 44 Common Core content standards for Algebra 2. Matrix multiplication is not commutative. In other words, if you take two matrices and multiply them one way and then another way, you're not going to get the same thing with one exception to that, and that's if you multiply by the identity. So what I've got here is I've got matrix C, which is the identity matrix. Now that's a 3 by 3. I'm going to go ahead and take A, which was 867530, and I'm going to go ahead and multiply A by C. I'm going to multiply A by C, and watch what I get. Now C is the 1, 0, 0. C is kind of weird. C is the identity matrix. If I multiply A by C, I'm left with the same thing that A was. Now if I try to multiply C by A, C is a 3 by 3 and A is a 2 by 3. I can't even multiply them that way. So again, to reaffirm, matrix multiplication is not commutative. So that's it. This is it for matrix basics. Make sure you study this material, read over it. It will be about 1/4 of Friday's exam. Have a great day. See you next time. Good.